All right, welcome everyone to today's webinar, Technology Trends Decarbonizing the Chemicals Industry. My name is Michael Holman. I'm a VP of Research here at Lux and moderating the session today. Our presenter is our Research Director leading our Manufacturing and Materials Research, Anthony Schiavo. So throughout the webinar, if you have any questions, please type those into the questions box on your screen. We will take some questions at the end. We'll get to as many as we can in the time. But if your question does not get answered or you have others as a follow-up, please feel free to email those to questions@luxresearchinc.com and we will get back to you. So with that, I'd like to introduce and hand things off to Anthony Schiavo.
Thanks, Mike. So today, we're first going to look at a quick snapshot of the CO2 emissions of the chemicals industry. Then we're going to dig into 3 technologies driving decarbonization. And lastly, we'll back up a little and think a bit more broadly about how to reduce the emissions impact of the chemicals industry. But first, chemical CO2 snapshot. Now, if you don't think that CO2 emissions are important, you can just get out. But when we look at the chemicals industry, we can see that it stacks up okay on emissions. It's about 3rd globally in these industry direct CO2 emissions. I think the challenge here is that a lot of these emissions are coming from not just direct sources, but also indirect sources, scope 3. Now, the IEA has a sustainable chemicals roadmap that they call for the next 20 to 30 years. They think about half of the decarbonization efforts are going to come from more conventional sources, coal to natural gas and energy efficiency. And then the other half is going to come from more disruptive innovations, things like carbon capture and utilization, alternative feedstocks, and plastic recycling. So in this webinar, we're really going to focus in on these more disruptive, technology-driven emissions reduction approaches. Breaking it down a bit further, the IEA is forecasting around 273 metric tons of reduction. Based on this pie chart, that's about, this is million tons. Based on this pie chart, that's about 95 million tons reduction from carbon capture and utilization, 24 million tons from plastic recycling, and 16 million tons from alternative feedstocks. So let's pick 3 leading technologies and just see how far we get when it comes to actually achieving these CO2 emissions reductions over the next decade. So we're going to look at CO2 to chemicals, recycling of plastic waste, and bioplastics. Now, this is not comprehensive, but I think this should be indicative of where the technologies are at and how much further we need to go in terms of actually achieving our CO2 emissions reduction targets. Okay, so let's dig into these 3 technologies driving decarbonization. First is CO2 to chemicals. This really includes, catalytic or microbial conversion of CO2 into useful chemicals and materials. It's interesting because it's both a fresh feedstock of potential carbons, to replace oil, natural gas, and it can be very sort of impactful in terms of total decarbonization. You're actually, both eliminating direct emissions as well as potentially creating a new material that's offsetting some additional production. The challenge here is really costs. CO2-derived chemicals are pretty expensive, and in a lot of cases, they don't offer performance enhancements over existing products. That can be challenging to sell them without those benefits. Now, what you see on the right here is the Lux Tech signal. This is a sort of combined index of data activity in innovation, so patenting, academic papers, government and VC funding, as well as our own proprietary data that our analysts collect. We take this and we compile it into a single benchmark of overall innovation activity. What you can see here is that there was some interest in the 2000s, on CO2-based chemicals. But it's really since 2012, 2014 that interest has begun to pick up, and it's been steadily growing here, really driven by a lot of academic and patenting work, as well as some light funding. Now, when you look at the CO2 to chemicals landscape, you can see there's a lot of different approaches: chemicals, polymers, carbons, proteins. In the chemical space, we see a lot of big names: BASF, Total, Mitsui. But I actually want to focus in on the polymers segment. I'm going to call out one company in particular. That's Econic. Econic develops a catalyst that can help react CO2 with a pretty wide range of epoxides to form polyols. And they have this tunable catalyst system. And what this does is this actually allows them to manipulate the properties to both increase the amount of CO2 that is put into the polymer, but also they can manipulate the properties of that polymer as well. That really helps give them advantages, not just in terms of absorbing CO2, but also in performance. As we talked about, that's one of the key issues here. Now, they don't plan to scale this up themselves. They plan to sell these catalysts to the established chemical companies. And we think that's smart. That's really the right business model. However, the challenge is really adoption. CO2 to polyols in particular, that's going to be a really small space in the larger sense. This is our forecast of overall market adoption for CO2 to different materials. What you can see is that in 2030, building materials are really going to be the dominant source here. And even though CO2 to polymers is going to be a fairly substantive market, we're only expecting it to offset about 1 million tons of CO2 in 2030. Most of the adoption of substantial CO2 to chemicals and CO2 to other spaces is going to be happening after 2030, as you can see here. And the biggest opportunity is really sinking CO2 into the building material space. So the driving force here is that there's a great potential to decarbonize basic chemicals, things like polyols. However, they're limited really by high energy costs and poor efficiencies. Chemical companies are probably going to have to pivot towards partnerships with concrete and other building materials players if they want to sink enough CO2 in the near term to really make a difference. And in the long term, fundamental R&D is still needed. The work is really still around catalysts, these fundamental process innovations. And that's where a company should be focusing. Okay, let's look now at plastic recycling. This covers really the conversion of plastic waste into useful products through a pretty wide range of mechanical, chemical, and thermal routes. And there's an opportunity here to address two crises simultaneously. You can divert plastic waste from the landfill while potentially reducing emissions, up to maybe 50% over conventional plastics. There's some key drawbacks though. Conventional mechanical recycling is fairly limited in terms of serving different types of applications, particularly food contact applications. And while there's a number of emerging thermal types of recycling, like pyrolysis, it's really not clear if those offer sustainability benefits, especially when compared to landfilling. Now, when you look at the Lux Tech signal for plastic waste recycling, you can see pretty steady or pretty uneven interest. But ever since 2013, we've seen some pretty strong growth there. That's really the same time that the crackdown on plastic waste and plastic waste trading began to take full effect, with countries like China beginning to ban imports and exports. So it's no surprise that we saw an increase in activity around that same time. Now, when you look across the space, again, you see a really well-populated startup landscape. There's a lot of companies in pyrolysis, but also in depolymerization and even advanced mechanical recycling. The chemical companies are active, certainly. You've got groups like Eastman, making pretty substantial investments. But in large part, they're doing this through partnerships and investments with companies. They're really leaning on startups for technology development. One of the leading startups that is really, I think, has a cutting edge technology is Ionica. They've developed a sort of a catalytically accelerated process for PET depolymerization. And their novel catalyst enables them to depolymerize PET in the presence of other contaminants, other types of plastic. They're scaling up a 10,000 ton facility, but it's really this catalyst selectivity that's hugely important. This allows them to take a waste stream that is otherwise too dirty to use and selectively use it. This is important because we really see waste streams as a crucial limiting factor for the scale of plastic recycling overall. Now, we've done a lot of work on recycling. We have a whole substantial report. I actually did another webinar that you can view on just this question of plastic recycling. So I'm not going to get into all of our opinions here, but we think the plastic recycling is going to grow to around 73 million tons from just under 20 million tons in 2018. This is going to offset a lot of CO2, 45 million tons of CO2 to be precise. And that's overwhelmingly going to come from just the mechanical recycling and PET depolymerization. Now, the biggest difference here in terms of how we're achieving this 45 million tons, it's just a matter of scale. We're adding about 40 million tons or so of additional recycling capacity over the next decade. And it's that 40 million tons of capacity that's going to drive this big offset in emissions. So when we look at this technology space, we can see the driving force is solving these two crises simultaneously. The limiting factor is collecting and sorting waste. That's why technologies like Ionica are so important. The key trend is going to be chemical companies directly building that mechanical recycling capacity. On that previous slide, you can see that mechanical recycling was really the dominant force behind that, both the scale up as well as the emissions reduction. And in the long term, pyrolysis does have a role to play, but it's really going to be the next generation catalytic pyrolysis processes that can really help both decarbonize and enable more widespread adoption. Lastly, I wanted to look at bioplastics. Here, we're talking about the conversion of sugars or potentially waste into conventional and novel plastics. The benefit is that you can reduce CO2 emissions. That's the primary driver here. But also, some bioplastics can biodegrade. This is potentially very exciting. You're potentially talking again about meeting these two crises simultaneously. However, the costs are high, and biodegradation is not nearly well established as an end-of-life route for plastics the way that recycling is. So there's a lot of controversy over if this is really a solution. Now, interestingly, when you look at the Lux Tech signal for bioplastics, what you can see is that we actually peaked in interest around 2015, 2017, and we've been slightly declining since then. That really coincides with, I would say, peak interest around some of the emerging performance bioplastics. When you look at the space overall, you can see that there's a really wide range of different materials. Polyethylene ferroanate, PEF, that was where a lot of that interest was in 2015, 2017. But right now, we're seeing a lot of activity down in number 10, the PHAs. People are excited about these polymers because they're both potentially carbon neutral or even carbon negative, but they also have really aggressive biodegradation capabilities. So there's a question, can these materials, these PHAs, come to scale? I want to call out Novomer. They're a new developer of PHAs, but they've developed a catalytic route as opposed to most groups which are doing fermentation. This should make it cheaper and easier to scale than biological routes. They're trying to scale up to around 80,000 tons by 2024. This is definitely a high potential technology. However, the challenge is going to be building the markets and creating the offtake agreements, getting people to accept and to use that product. So it really, remains to be seen if they can create demand for this PHA product. one of the potential concerns, one of the potential limiting factors is that while bioplastics offer lower CO2 footprint, they do carry other risks. There's a risk of increasing land usage, especially if you are farming a dedicated crop to turn into a bioplastic. Some bioplastic production routes actually have higher energy consumption overall than their more conventional compatriots. For a lot of these materials, again, if you're using a dedicated crop, water consumption can be a lot higher. And that's going to be increasingly a concern as drought becomes more of an issue with climate change. And lastly, there's that issue of waste and end of life. Like I said, biodegradation is inconsistent, and there's not a lot of agreement over whether or not it really constitutes an acceptable, end of life route. Over the next decade, we expect to see most of the scale up actually occur in these more conventional bioplastics, things like polylactic acid and bio-based PET. The more disruptive, more exciting things like PHAs, those are going to remain a much smaller portion of the market probably this decade. And they're going to take more time to come to scale. And like I said, they're going to take time for people to accept those end-of-life properties, as well as to create the right products that can really leverage these materials. So this scale up of about 2.5 million extra tons, that's going to offset 3 million tons of CO2 potentially. And I will say that this is a fairly conservative estimate. You could potentially see this be double, up to 6 million tons of CO2. And certainly the potential here on a material basis to offset CO2, it's definitely higher than recycling. But since the overall scale of bioplastic production is going to be a lot lower than recycling capacity, the overall impact is going to be a lot more limited. So when we look at this technology, the driving force, it's really about finding alternatives to petrochemical feedstocks. But the limiting factors are costs and these unclear sustainability credentials. The key trends, regulations on single-use plastics. In China, a ban on single-use plastics has an exemption for PLA and other biodegradable materials. That is what's creating a lot of incentive to scale that material up. So we're going to need to continue to look to regulations in order to really achieve further growth in this space. And in the long term, you can actually expect a split between Asia and the rest of the world, driven in large part by those regulations. So we expect to see a very different environment in Asia Pacific, in China in particular, but also in Southeast Asia. In addition, there's a lot of biomass availability in Asia. So you can really see Asia and Southeast Asia become a hub for this type of activity, nations like Malaysia and Thailand in particular. Okay, we've looked at 3 technologies. Let's come back to these goals. These are the IAA goals for CCUS, alternative feedstocks, and plastic recycling. That's the total of 273 million tons of capacity or emissions reduction overall. And just from these 3 technologies, you're looking at somewhere like 100 and 110, 120. Our Lux projections of decarbonization, well, plastic recycling really outperforms the IEA, what they expect, in part because of our projections of aggressive scale up. But this is only 49 million tons of emissions reduction. Now, it's fair to say that this is not a complete snapshot, right? There's a lot of other things happening other than CO2 to chemicals. You could use carbon capture and store that carbon. You could sequester that carbon into concrete. But I think this really shows that we're pretty far away from solving this issue with pure technologies. Even though this is a conservative estimate, the chemicals industry is going to have to look at more than just technology, and they're going to have to look at more than just materials and chemicals that they already make. Looking at carbon, looking to looking at concrete, looking at these other markets and value chains. But I want to question one of the fundamental assumptions here of this IEA and of what we've been talking about. In the IEA's sustainable chemicals outlook, they assume that demand for chemicals is going to go up, and it's going to go up a lot. But sustainability and volume growth are really fundamentally opposed to each other. if you're growing the amount of material that you're producing at 3 or 4% a year, it's going to be a lot harder to achieve those decarbonization goals than if you have 1% growth or 0% growth. But obviously, 0% growth is not a very good way to run a business. So there is a need for new business models that can divorce revenue growth from volume growth, because reduced consumption is going to be key in order to both reduce costs for end users, but also improve sustainability. Now, we've already seen companies begin to experiment with new business models that change how the revenue is being generated. In agrochemicals, Bayer is working on outcome-based selling, where they actually get more money if the yield of their crops, of the crop of the farmer, is actually good. And in a complete shift, Ecolab, a producer of cleaning chemicals, is now charging its customers on a per room to clean basis, not on a per volume of chemicals basis. With this, Ecolab's incentives are to reduce chemicals, same as their customers. So this is really creating alignment, and it's creating a situation where they can reduce the amount of chemicals consumed and produced while still making more money. Now, in both cases, digital technologies are really crucial. When you're talking about measuring outcomes and selling based on outcomes, you need a digital technology to measure that outcome. So digital transformation is actually going to be really crucial to these new business models. But it's not just about measuring things or changing the way you sell. You can also add new products and services. I would call out AkzoNobel's Dry Dock Insights as a great example of this. This is a software system that helps their customers of paints predict corrosion, fouling, and ultimately tell when they need to bring their boats back into service. Now, you can use this just to sell more paint, and that's fine, that's level one. But in the long term, these types of services will become a revenue stream all on their own. And that's going to help reduce the impact of reduced sales of volumes. So I just want to leave you with a few final thoughts. First is that decarbonization is a pretty complex task. It requires both incremental and disruptive innovation, and there's a lot of different technologies and approaches. We've covered 3 here today, but this is certainly far from a comprehensive view of everything that's going to contribute to decarbonization. Secondly, chemical companies need to learn to navigate upstream and downstream systems, whether it's selling new types of services to their customers in order to move away from volumes, or managing bio-based resources or plastic recycling. There's a lot that's going to push the chemicals industry out of their traditional areas of expertise. And lastly, is that these new business models are going to emerge, and they're going to help decouple revenue growth and volume growth. So if you're thinking about decarbonization purely in terms of technology, you're really missing the bigger picture. With that, I want to thank you for your time and your attention, and we're going to open it up for questions.
Great, thank you very much, Anthony, for that presentation. We've had some questions coming in. We'll have some time to take those now. Again, as you see, you can type those into the questions box. And if we don't get to your question on the call, someone from Lux will be in touch about that afterwards. Anthony, maybe just to start off with one more of a technology driven question here. What is the role and opportunity for CO2 storage in all of this industry decarbonization?
Yeah, I think it's a real question. We did a pretty substantive report, and my colleagues in the energy team are definitely the experts here. We did a very substantive set of reports on this topic. And it really is a question of what happens with electricity prices and what happens with regulations, right? A lot of these CO2 to chemical technologies, they rely on really cheap green hydrogen. They rely on very fundamentally cheap electricity and cheap energy. So if those energy prices can come down enough, you can see CO2 to chemicals and a lot of things sort of enabled by green hydrogen really become cost effective compared to carbon capture and storage. But if electricity prices remain high and carbon taxes become high, that's going to push the industry more in the sort of the direction of carbon storage. I think ultimately carbon capture and utilization is where we want to end up. I think that's just a more attractive business model overall rather than storage. I think there's a lot of questions about storage's effectiveness. But really it's going to break down to the technology development, the level of the energy system, how that transitions. So if you're in the chemicals industry, you really need to be tracking the development of this novel energy system. The other thing I would highlight is energy shipping, green energy shipping, things like hydrogen, energy trading is going to be really crucial, because often that really cheap energy is not going to be where the chemicals existing production already is. So there's a lot of interrelated systems that are going to develop over the next decade and 2 decades even, that are going to kind of ultimately dictate where we land in terms of utilization versus storage.
But from a sort of an innovation standpoint, at this point, you should really be looking to hedge, have a portfolio of bets at this point.
Yeah, I think you need a portfolio of options for sure, because there's going to be a lot of regional differences. There's going to be a lot of legal policy differences that make a change. There's just going to be a lot of it's not all just going in one direction for sure. It's going to be a very sort of fractured type of situation in the next decade.
Yeah, so here's another one that we get from a lot of our clients as well. What are the opportunities? What ways for looking at this as an opportunity for chemical companies? So what are the ways that chemicals companies can help to enable decarbonization in other industries?
Yeah, I think that's a good question. There's certainly opportunities in, I think, the automotive sector, and a bit more broadly in transportation. But fundamentally, I think the biggest opportunity is in the built environment, not just because it's a huge consumer of or a huge emitter of CO2 reductions, but also because fundamentally, I think the built environment really needs to be reorganized, right, in order to achieve a low CO2 emissions, right? Suburban living is not a very CO2 efficient way of doing it. And so there's a lot of, innovations, whether that's things like, prefabrication of buildings and prefabricated concrete, maybe 3D printing of concrete, but also just things like insulation, fire retardant materials, all these things that flow into the building and construction space, not necessarily reducing CO2 on their own, but enabling people to live in a built environment that's conducive to a low CO2 sort of lifestyle, taking public transit, not having a personal car. All that is going to require a big reorganization of the built environment. And I think anything the chemicals industry can do to make it easy to construct buildings with more local materials, to be compliant with codes while having a very high density of, sort of living density, all that stuff is going to be really crucial. And there is going to be a really fundamental change in terms of how the building, the built environment is thought about over the next decade or two, I hope.
Yeah, so maybe one last question we'll have time for it. You mentioned this dematerialization and these new types of revenue models. So someone asked, how should companies organize to pursue these type of new revenue models? And maybe say, what types of different roles or processes or incentives might they need to put in place to be able to kind of successfully innovate along that axis?
I think it's going to require like combining a lot of different sort of, particularly like the more marketing focused roles with these more traditional innovation roles, right? One of the things we've heard a lot from customers and from clients who are experimenting with this is like, when people think about, these new business models, their initial reaction is, hey, you're just trying to sell me less stuff for more money. You're just trying to charge me more money. So there's a real need to overcome that hesitancy. And I think sort of driving the sustainability, linking these new business models to sustainability outcomes that people care about is really crucial. But that really requires like a full sort of marketing and communication sort of element, right? So I think it's really going to be crucial to get the R&D people, the marketing folks, sustainability folks, all swimming in the same direction, all pulling in the same direction on this, because it's going to be crucial to communicate why these business models are important and how they actually achieve these goals.
Okay. All right. Well, thanks, Anthony. That concludes the webinar for today. The slide presentation and recording will be sent out to all attendees by email later today. After leaving the webinar, you'll be prompted to complete a survey. So please do take the time to respond to that. It really helps us to improve these webinars and make the next ones even better and more relevant for you. So thanks again for joining us, and have a great day.